Now, the threat assessment will use the outputs of the security policy and the security interconnection documents, because it needs to identify potential attacks. There is already a lot of the dream space, and this is a threat for the existing spacecraft. Another threat is the jamming of the uplink, unauthorized traffic that will take the place of the authorized traffic and prevent communication. Another threat is the possibility of replaying the telecommands or to counterfeit them. The telecommands are not secret, they are all published in big books, manuals. So with the proper means, building a fake ground station, a third party, an adversary, could fake the telecommands and send them to the spacecraft. The other direction, there is the risk of intercepting the telemetry, the data that comes from the spacecraft, or the payload. Stealth of payload. At the ground stations, there is a need to protect from unauthorized access, from insiders via the information system. They have access to the information system, but they do things they shouldn't be doing, or from outsiders that trespass the boundaries. There is a threat of social engineering. Very able people that can get access to secrets by convincing the authorized people to give them out. There is a threat of intercepting the payload data on the ground network, the typical threat of obtaining spoofing or capturing, intercepting internet traffic over the ground network. There is threats from software. This sounds silly, but the biggest disaster of the history of ESA was the 501 failure of the launch of the 501 Ariane launcher in 1995, which was due to a software problem. And of course, the hardware failures that can be happening on the spacecraft or on ground equipment. So what do we do as countermeasures? Space elements. What do? We make them redundant. But also on the spacecraft, everything is always redundant. 2, 3, 4 processors that are there to do the same thing. So if one fails, there are always another one that takes over. And this is always the case for spacecraft. Redundancy at the level of the model, redundancy at the level of each single component. Situational awareness is a new project that ESA started, which is aimed at mapping the debris, knowing exactly where they are, knowing what they are and where they are at any given time, so that if there is a threat, this threat can be put in a control system and then acted upon by particular countermeasures. For the up-down link, we'll focus more on this one. We need typical cryptographic measures to authenticate the telecommands or to authenticate the telemetry, depending on the needs, to make sure it's coming from particular origins. Or we can also want confidentiality. We want to protect the contents of the data for some reason. So we apply the crypto not only to the digest of the message, but to the message itself. But then this creates problems with key management, because when we do crypto, we need keys at both ends. And so we need to preload keys on the spacecraft before launching, and then to use these keys as key encryption keys to refresh them periodically on the spacecraft. Then for the Earth protection is more typical. The typical security is physical security, so the ground stations, being valuable assets, need to protect them with fences and guards, traditional. Personnel need to be trusted, so we need to build a mechanism and measures to have trusted personnel on board of these specific installations. And typical measures of information system protection, like encryption of the ground links, authentication, hardened systems, especially those who are facing the internet, and things like this that are typical. They don't particularly belong to the space work, but belong more to the information system.